All right, so moving on now. We're going to look at the factor theorem, right? So for a polynomial p of x, x minus a is a factor of p of x if and only if p of a equals 0. So what this means is if you were to take x minus a, right, set it equal to 0, solve for x equals a, and then we were to evaluate function p for a. So we'd place a into all the x's in that polynomial. The output would be 0, okay? Or another way to look at it is if we were to divide the polynomial p of x by x minus a, the remainder is 0, okay? And remember, if x minus a here is actually a factor of this polynomial, then that also means that a here is a root if it's a polynomial equation, or a 0 if it's a polynomial function, right? So here we go. P of x equals 2x to the fourth plus 5x cubed minus 8x squared minus 17x minus 6. Determine whether each of the following is a factor of P of a, right? So the way we can do that is simply by looking at this first one here. Let's do it in red. X minus 1, right? So we take x minus 1, set it equal to 0, solve for x equals 1. So we're basically checking, does x minus 1, when divided into the polynomial p of x, produce a remainder of 0 to verify it's actually a factor or not, right? There's my mouse. Okay. I'm struggling with this here for a second. How does this work? No. Okay. So, still recording. Okay. Let's jump this page up a little bit. So we're going to set up a synthetic division idea with our coefficients 2. Again, make sure it's in standard form before you do this. Make sure you don't need any placeholders. And then we're going to drop a 1 in here, right? So we add 2 plus 0, 2, multiply 2, add 7, multiply 7, add negative 1, multiply negative 1, add negative 18, multiply negative 18, add negative 24. This is not 0. Therefore, x minus 1 is not a factor of p of x. And then we try it again for b, x minus 2, right? So we just repeat the process, right? Set up your synthetic division. Testing x minus 2, right? So x minus 2 equals 0. So we're going to check x equals 2 here. We're going to place a 2 in here and go through our process one more time, right? So 2 plus 0 is 2, multiply 4, add 9, multiply 18, add 10, multiply 20, add positive 3, multiply 6, 0. Okay, now that this is a 0, that means x minus 2 is a factor of p of x. Not only does it tell us that x minus 2 is a factor, it also indicates that x equals 2 is a root or 0 of p of x. In this case, it was presented as a polynomial function p of x, so we would actually classify it as a 0 in this case.